Hi students, in today's experiment, we will be looking at the displacement reaction of metals. The chemicals that we will need are a beaker of copper 2 sulfate solution, as well as a strip of zinc metal. What do you think will happen if we were to place this piece of zinc into the solution? Let's find out. We observe that as the reaction proceeds, the solution changes from blue to colorless. In addition, a reddish-brown solid also forms on the surface of the zinc metal. So what is the chemistry behind this? Let's take a look. This is a beaker of copper 2 sulfate solution. The solution is blue due to the presence of the copper ions. What will happen if we add a piece of zinc into the solution? Let us take a closer look at the reaction. The piece of zinc metal is made up of many zinc atoms, which are packed regularly in layers. If we take a look at the reactivity series of metals, we know that zinc is a more reactive metal than copper. As a result, zinc has a greater tendency to form positive ions. This can be represented using the ionic equation as shown. In forming the zinc ion, zinc metal loses 2 electrons. Thus, we can say that zinc is oxidized. Copper, on the other hand, is a less reactive metal. Thus, it prefers to remain as an atom instead. This can be represented using the ionic equation as shown. The copper ion that is present in the solution takes in the 2 electrons to form copper. Since the copper ion gained 2 electrons, we can say that it is reduced. Over time, as the reaction proceeds, more zinc ions go into the solution and more copper atoms are being deposited onto the surface of the metal strip. As such, we can say that the more reactive zinc metal has displaced copper, the less reactive metal from its salt solution. Now, let us check if you have fully understood the concept of the reactivity series of metals and how it directly affects the displacement reaction of metals. Over here, we have a beaker of colorless zinc sulfate solution and a strip of reddish-brown copper metal. What do you think will happen if we were to place this piece of copper into the solution? Let's find out. We observe that there is no reaction between copper and zinc sulfate. Why is this so? If we take a look at the reactivity series of metals, we know that copper is less reactive than zinc. Thus, Both the copper atoms and zinc ions are happy to remain in their original states in this case, and no redox reaction occurs. That's the end of our lesson today, and I'll see you in the next one.
Precious metals like silver and gold are unreactive. This makes them ideal for making jewellery and ornaments. At the other end of the spectrum, metals like lithium, sodium and potassium are so reactive they can be dangerous. But there's a wide range of metals in between, and seeing how they behave in different solutions can help put them in order of reactivity. Placing the metals in lead nitrate solution provides our first clue. Silver doesn't react, and neither does copper, but magnesium and zinc both become coated with a dark grey layer of lead. Magnesium and zinc are displacing the lead from solution. Placing zinc metal in a magnesium solution and magnesium in a zinc solution will help determine which of these two is more reactive. Nothing happens to the zinc strip on the right, but magnesium reacts instantly, displacing the zinc from solution. Magnesium is the winner. It's the most reactive. But which is the least reactive? Silver is placed in a copper solution, and copper in a silver solution. The silver strip doesn't react, but the copper immediately displaces the silver. You can actually see crystals of silver growing on the copper strip. After several hours, there's so much silver it glistens, and the colourless solution is starting to go blue. So, magnesium is the most reactive and silver is the least. What would happen if you placed a strip of magnesium into a solution of silver nitrate?
In this lab, we are reacting 5 different metals in a single replacement reaction with 1 molar hydrochloric acid. From left to right, the metals are aluminum, copper, iron, magnesium, and on the end, zinc. So to each test tube, we will add an amount of hydrochloric acid, and we will measure its reactivity. You'll see there's a small amount of bubbling in the aluminum. There's no change in the copper. Very little change, if any, in the iron. Significant change in the magnesium, and also significant reaction in the zinc.